two charges each is equal to -4, okay, coulombs or microcoulombs are held at a certain distance apart. A charge q is placed exactly at the midway between them. The magnitude and the sign of this capital Q, so that the three charges remains in equilibrium. We have to find it. Clear? So let's make a rough diagram. So first diagram over here is, let me just make it and let me decrease here this thing. Okay. So here let's say this is our A and let's say this is our B. Correct? And this is the line joining the two charges. Correct? And here this is our O. This is our separation R between A and B. So this gap will be nothing but R by 2. Correct? So charge Q1 will be -4 microcoulomb as per the question, and this will be also 4 microcoulomb as per the question, right? This is our center Q. I hope this is clear, right? Now what you have to do, you have to find the magnitude of this capital Q so that the whole system remains in equilibrium, right? The system will remain equilibrium if the net forces, okay, they will cancel out, right? Just now we have seen in the previous question, if they are cancelling out, net force is 0, and net force is 0 means they are in equilibrium. So simple concept, right? So what we will do here is, we will first find the force between the first charge A and O and the force between A and B. Clear? Let me repeat again. The force we will find, because previously when this Q was not there, they were having some repulsive force between them, right? A and B were having some repulsive force between them. Due to the presence of this Q, they are affecting this repulsive force. So we will find, because both are equal charges, right? So first we will find force due to A or B, let it be, because both are same, right? So force on this O, let's find it. That will be equals to how much? Okay, that will be equals to K, which is 1 by 4 pi epsilon naught. Q is first one, this second charge is 4 into 10 to the power minus 6. Again I am repeating, negative sign is not considered, but resultant is 0, which means net will give you 0. So you will subtract them at the end, right? So this is the force, whole divided by separation R by 2. Yeah, no matter if you consider A or B, both have same, and separation also R by 2, right? Okay, clear it is, I hope. So this is R by 2 whole square, K Q1 Q2 by R square. Okay, now let's find the force, repulsive force acting between A and B. So repulsive force between A and B will be equals to 1 by 4 pi epsilon naught. First charge is 4 into 10 to the power minus 6, second charge is 4 into 10 to the power minus 6 whole divided by separation. Now separation is R square, correct? Okay, now this force is resulting in 0, which means F naught minus F is equals to 0. It has to be 0, then only they are in equilibrium, right? So let's substitute, or before substituting, let's take on the other side like we did in the previous problem, so that things will cancel out. So let me substitute here F naught, which is 1 by 4 pi epsilon naught Q into 4 into 10 to the power minus 6 whole divided by R by 2 whole square, and that is equals to 1 by 4 pi epsilon naught 4 into 10 to the power minus 6 into 4 into 10 to the power minus 6 whole divided by R square. Let's cancel out what are the things which are getting cancelled, correct? So here this thing will cancel out, our 4 pi epsilon naught is getting cancelled, and 4 into 10 to the power minus 6, one of them cancels out. We left with here on the left hand side Q upon R square by 4, R square by 4. So let's take that 4 on the top. You can keep it below, your wish, okay, but it will eventually go on the top, and that is equals to 4 into 10 to the power minus 6 whole divided by R square. Let's cancel out R square both the sides. So cancelling R square both the sides, Q will be equals to 4 upon 4, 1 into 10 to the power minus 6 coulombs. Clear? So this is our charge. If you go back, the question says what will be the magnitude and the sign. See here both the charges are negative. So to keep them in equilibrium, this must be positive. So correct answer is option A, positive 1 microcoulomb. I hope this is clear.